All right, so we see our 5 steps just succinctly written up there in the corner. Let's try example number 11. We see that our differential equation is x squared times y squared, and we're trying to solve that. We're trying to get y equals y being a function of x. And we know our initial condition is that when x is 0, y is 1. Right? So what does what's the solution look like? All right, so step 1, separate the variables. So if we're separating the variables, we have a y term on the right side, which we want to move over to the left, and we have a dx term on the left side, which we want to move over to the right. So in order to move those, we just have to multiply and divide accordingly. All right, the dx is always going to be multiplying, all right, because that will allow those dx's to wipe each other out on the left side. The y term, well, we can see that this is x squared times y squared, so we're going to want to divide by y squared in order to get that y out of there on the right side. All right. So by now making those algebraic operations, we have dy over y squared equals x squared dx. And we've separated the variables. And on the exam, if you do this, then you would earn one of the 5 or 6 points. You have to separate the variables. If you don't separate the variables right away, you're out of luck for points as far as the entire section of the question is concerned, because this is the only way that you can solve these differential equations is by separating the variables. All right, so now we have to go and take the antiderivative of both sides. All right, so we have the antiderivative of the left side and the antiderivative of the right side. Okay. When we derive, we have dy over y squared. Now, some students look at that and say, oh, y is in the denominator, it's got to be natural log. That's not the case right here. Maybe we should rewrite this ever so slightly. Keep in mind that this is y to the negative 2 dy, and obviously x squared dx there, okay? If we have a 2 and the exponent of the denominator, that means that it becomes negative when we move it up to the numerator. And now when we antiderive this, we're just doing a reverse power rule. So we're going to add 1 to the exponent. So we have y to the negative 1 over negative 1, okay? And then over here, when we add 1 to the exponent, we have x cubed over 3. Okay, so we've antiderived both sides, and if you do that correctly on the exam, you will earn 1 or 2 more points. If the antiderivatives aren't that bad, and these are considered to be not that bad, then it's probably 1 point combined for both antiderivatives. But if one of the antiderivatives can be a little bit hairy, then what will end up happening is you'll get a point for doing one point for each of your antiderivatives, which you find correctly. All right, so we have y to the negative 2 going to y to the negative 1 over negative 1. X squared going to x cubed over 3. Now we get to step 3, which is don't forget the plus c. And again, initially there's a plus c on both sides, but we're going to combine them together over here on the right. So we have that x cubed over 3 plus c. And again, writing plus c on the exam with some antiderivatives is going to get you another point. All right? Another point can be earned by trying to figure out what c is, but you have to use the initial condition. Our initial condition is right up here, and we know that when x is equal to 0, y is equal to 1. Right? So we're going to plug 0 in for x, and we're going to plug 1 in for y down here. Right? And as I'm plugging in 1 for y, I'm also going to rewrite this because it's going to be easier to plug this in if I have a general idea what's going on over here on the left side. We know that y to the negative 1 means that y to the first power down in the denominator. So what we're looking at here is we have this 1 over, and we got our negative sign, and then this y, again, is moving down into the denominator. Okay, that's just our algebra skills in knowing how to move positive and negative exponents. Right. And then over here on the other side, again, we still have x cubed over 3 plus c. We're going to plug in 0 for x, so we have 0 plus c. We're going to plug in 1 for y, so that's negative 1. So we can see that c is negative 1. Okay, so we now go back to this differential, this solution right here, all right, which is 1 over the opposite of y, and that's equal to x cubed over 3 minus 1. Okay, and we have to solve for y. We have to get y all by itself. All right, and there are multiple ways that you could do this depending on which steps you do first. You should know that on the exam, if you're asked to do this, that the readers will accept many answers based on how you chose to simplify your answer, how you chose to get y all by itself. So as long as you're doing let's call it legal math, you're going to be okay, even if your answer doesn't look exactly like what your neighbor has. Right? So basically, we want to flip this, don't we? We don't want the y in the denominator, we want the numerator. So we're going to flip this left side. We're going to reciprocate it, which means we have the opposite of y over 1. And we don't need to write the over 1. Okay? But if we reciprocate the left side, we have to reciprocate the right side. So this is x cubed over 3 minus 1. All right, so that means if we get a common denominator, this 1 is really 3 over 3. Okay, and if we have a common denominator, we don't need to write that denominator once now. So we now have x cubed minus 3 all over 3. So when we reciprocate that one, we now have 3 over x cubed minus 3. Reciprocate the left, reciprocate the right, just as we see it. Okay, and now we just don't want a negative in front of our y. We want y all by itself, right? So we just negate everything. So we have y equals negative 3 over x cubed minus 3. And this is our solution. Okay. And it does say what's the domain of our solution, and the domain is important. We can see here clearly that we don't want to divide by 0. All right, divided by 0 would not be a good thing. So let's see, that means that x cubed minus 3 cannot be 0. So that means that x cubed cannot be 3, which means that x cannot be the cubed root of 3. Otherwise, all of the values of x are okay.